Hello everyone, this is Gary Marr from Arizona State University. This screen capture is from my ASU IFT101 class. In this screen capture, I'm going to go through a sample program in Python, a very simple one to start off with. But I guess more importantly, I'm going to be using an IDE, which stands for Integrated Development Environment, different than IDLE, which is the IDE that comes with your Python download. Now, the reason I want to use Thonny is that it is an IDE that was developed specifically to learn Python, and it does have a few features, specifically a debugger, which is very handy when trying to find logic issues with your code. It looks more like what most of you will experience when you take other programming classes in Java, C#, etc., because IDEs are the main tool used by programmers for developing and testing their code. And you'll see that in place here in a couple of minutes. Now, after you start Thonny, it's got a ribbon on the top here of icons. It's also got pull-down menus. The file has got a new file, open a file we've worked on, much like IDLE or Notepad or other products that you may have used. The editor, nothing really fancy here. This is a slimmed-down IDE. There's a lot of IDEs that support Python. A lot of them are free. That's one of the nice things about Python. But this one is developed specifically for educational purposes. I think it has been made simple by default. The view is going to give you different windows. By default, I typically just go with the shell window, which is in the bottom here. Python, the way we're going to learn it in this class, is primarily console applications, which is not going to be GUI code. GUI code is available with Python, but we're not going to do anything with it in this class. The other windows that are important, the assistant window can be important, and variables can be important when we actually take and debug one of these programs with a debugger. Now, that's something I'll do in a different video a little bit farther into class. You can play around with these, look at them, see how they work. It's not going to hurt anything. The run button, run option, essentially copies a lot of the material that's on the menu bar. I don't find myself going in here very much as I'm in the menu ribbon. Device, nothing there of any great consequence. This one, I typically like dark backgrounds, but if you go into options, you can place a theme out there that maybe has a white background or a color selection you're more comfortable with. This has the code highlighting. So what happens here is keywords like, let's see, print will be a blue color. Light blue will be programming comments. Literals, string literals are green. Number literals are orange. Variable names are in white. Again, these are visual cues to hopefully help you look at the code quickly and maybe find things a little faster than if everything was just white with black letters. When it comes to running the code, there's a run button up here, the old VCR metaphor. And when I run it, what you'll find happening is the bottom part of the screen is where the action is. This is the equivalent of a DOS command prompt, or if you're an Apple user, terminal mode. And this is the only kind of applications we're going to really work with here because the emphasis in this class is on programming structures, not developing GUI or Python code with a lot of sophistication. So this is a simple average program, so I'll put my first number of 6 in there. I'll put my second number of 7 in there, and when I hit enter, it's going to calculate 6.5 as my average. So it seems to be working from a testing standpoint. And one of the nice things about IDEs is let you modify the code or fix the code on top and then test it down the bottom. So for example, if I took out something here so it would force an error, since Python is an interpreted code, it always runs until it cannot execute that line with the the CPU. So if I hit run now, that one didn't get very far at all because the first executable line of code was the one that I ended up taking the parentheses out. It'll give me a syntax error. It will give me some information that's kind of like a call stack. It will essentially point to where it thinks the problem is. And yes, in fact, I've unmatched parentheses. So when I insert this back in there and save my program and rerun it, Shazam, I now have a working program again. Okay? So what I'll be doing in the course of the class is going into Thonny. I don't think I'll use any other IDEs, but there's many out there, to show you some examples in Python and how it maps back to the logic we're working on in class. Now, as far as the rest of this program goes, program comments are there to give additional description for anybody looking at the code to help them better understand what's going on. What I've done is I've declared some variables that are global on the top of this program. I've initialized them with the appropriate data type I want stored in there. Now, it turns out I must have had name in a previous version of this because I don't see name showing up now. So I could probably delete that or take it out, which I will. Or the other thing that happens a lot of times with programmers is that when you have a question about a code line and you're not sure if you want to take it out yet, I can simply comment it out so it won't execute. I've got three variables, excuse me, first number, second number, average, all initialized zeros, all going to be integers. When the program moves further, I then go from the declaration of variables to the input part of my program. And the input for processing output matches a lot to some of the diagrams that you've learned in Module 2 and also in Module 3. Pretty much all of those diagrams have asked you, at least before you start putting together any algorithmic code or programming code, to lay things out in some sort of fashion so it can easily be put into a program. In this case, I have inputs, processing, and then down here is outputs. So in the inputs, there's my variable. Okay, I've got int and input, which are light blue or lighter blue, so those are actually keywords. What's happening there is the input is a built-in function that comes with Python. It uses this string literal as a prompt. When it captures the information, the data type by default that returned by an input is string. Since I can't do math with a string, I need to change it to a numeric data type. I chose int for the first number and the second number. So when I've executed lines 11 and 12, I now have variables in memory. I'm at a memory location that these two variables know about that have values stored in there. Below that, I actually have created a new variable called average. Okay, it's going to take the first number times the second, plus the second number, and divide it by the number of values at 2 to give me an average. So it's a simple average calculation. The one thing I could do if I would like to is I can also, this will default to data type float, but I could also force that issue by not only using int as a built-in function to convert this to an integer, but to convert this number here to make sure it's got decimals. But it should do that by default, and that's called casting. At the end of the program here, I've got another comment saying this is my output section. Print is a built-in function of Python. That's why it's colored the same as input and int. Those are all built in. Average is what's called a string literal. It's the same string literal type that I used up here for prompts. This one's going to show up in my screen. It's going to say average is, and you can see it down here. A space, comma. The comma is a concatenation operator in a print statement. Sometimes you'll use a plus, and a plus when you're working with strings is concatenation. If you're working with numbers, it's arithmetic. In this case, print has a special concatenation operator called just a comma, and then the word average. So you can see the result of this program running down below here. The prompt for the first number, there's my first number. The prompt for the second number, there's the number. And then finally the average is printed out to the screen. This is using the Thonny IDE. You get very similar results with IDLE. But I kind of like Thonny because it's got some other features that may come in handy as we get into some more complicated Python code later in class. Hope this helps.